first presenter, and our first presenter is Stefano Tempesta, who is already here, who is a senior program manager at Microsoft, and he is one of the only 160 of the world's top technology visionary Microsoft regional directors appointed by Microsoft specifically for their proven cross-platform expertise, community leadership, and a commitment to business results. So he's going to speak on data protection in the cloud. So, hello, Stefano, how are you?
Hi, thanks for the introduction. Thank you for having me today.
Thank you so much for joining us. Thank you for your time. We are honored to have you as a keynote speaker. So, Stefano, you can share your screen so that I can check that is it properly working or not.
Yes, let's do that.
Okay,
Here
sure.
we go.
Yeah, I can perfectly see it. So, good luck. Stage is all yours now.
Excellent. First of all, thanks everybody to be here and investing your time for an event that I believe is so important. Cloud security, security in IT. We see so many data breaches nowadays that having the proper security strategy and technology in place is so essential. So yes, the topic for today is data protection in the cloud, but I want to focus on a specific type of protection because security is so broad. We will stay here the entire day to speak about security, and you will hear from the other speakers different flavors, different strategy, different technologies from security. But today my focus is on a special type of security that protect data when it's being used, so when it's actually being processed and it is in memory. I'll get into that in a moment. Let's get through a few slides so we can position and contextualize today's session. Now, I don't have to tell you how important it is to protect your data. We hear daily about news on data breaches, and all of them have an impact, right? So from stealing data, so confidential data that is taken away from banks, health organization, governments, and obviously at the end from private citizens, as well as the financial impact of it. How much is going to cost this organization to put some proper strategy and technology in place to prevent the data breaches in the future? Now, there is an aspect of this that is specific to data being processed, as I mentioned before, data that is used in memory for analytical computation, for multi-party machine learning. I'll give a few examples in a moment. But in general, the context is when data is in the cloud, there are three aspects of data manipulation, data processing. The first one is the storage itself. Where is this data stored? In some infrastructure. And we trust the provider of that infrastructure, whether it's Microsoft Azure, AWS, Google Cloud, Alibaba, to protect our data. So we put a trust in the cloud provider. Then there is a component of data being transferred. You have to use this data, right? So you're not just storing it. HTTPS, express route, VPN, whatever secure channel you want to put in place. And again, you're trusting the communication channel for processing your data in transit, in motion. And there is a third component, which is, we want to make sure that also no one else inside the cloud provider infrastructure, inside the data center, has access to this data. So this is where we see an aspect of this data protection that is typically neglected as part of our cloud security strategy. How secure is the data center itself? Can we get access, physical access, to the hardware inside the data center? can I trust the administrator of the data center, not the host, that they don't access the hypervisor and check what's going on into my virtual machines, into my containers? But also, how secure, no, from patching, antivirus, web firewall, network protection in general, is the host and the guest infrastructure, operating system, and all the aspect of hypervisor, virtual machine, all the aspect of virtualization in general. So can we trust all these elements? And the short answer is we can't. This is the concept of zero trust. You, as a consumer of this data, have to be sure that you put in place the necessary strategy and the technology for protecting your data. Yes, there is a level of trust that you have to put somewhere for sure, right? But don't rely on that as the only guarantee that your data is 100% secure. There is no such a guarantee. No one, no Microsoft, no Google, no AWS can guarantee data security 100%. There are several SLAs in place, security level agreement, service level agreement, but in ultimate responsibility is yours. So how can you mitigate the risk of your data being leaked or compromised, especially data that is not being processed inside these data centers? One of the best strategies is to reduce the attack surface. What an attack surface is anything where data is hosted, file system, database, virtual machine, the network to connect to, the memory, the RAM, where it's been loaded and executed and been processed by an application, is a surface. Any system. So all these systems are potentially vulnerable. So they represent an attack threat. So we need to reduce it. So we need to remove as much as possible access to these these surfaces. One of the typical way of doing it is with role-based access control. So you assign some people or some applications to some specific roles, like you can only contribute, you can only modify these, you can only read, so read-only access. We try to reduce as much as possible what they can do, rather than having admin access to everything and then obviously exposed to an increased risk. But there is an aspect that a few organizations still neglect today, which is reducing your trusted computing base, your TCB, as much as possible to only some specific components of the entire solution, hardware, firmware, and software, that will limit the exposure to attacks, that will limit the attack surface. This is part of the entire data protection lifecycle. We are already familiar with the concept of encryption data rest. Years and years, all the databases, all the file systems nowadays, across all the operating systems, including mobile operating system, provide encryption data at rest. Your data, when it is stored, is encrypted. Peace of mind. So we are reducing the attack surface, right? Because data is protected when it is stored. And the same when it is in transit. HTTPS is a mitigation to attacks that may happen on the communication channel. So we are reducing the surface of attack over the channel. But there is still another component that is missing in the picture. And you see the empty space in the slide. When data is taken out of the database, for example, and is being transferred in a server, virtual machine, containers, wherever you're processing this data, in that moment is actually in clear. So if someone took a memory dump of what's running in that moment, they will see your data. They will see also your secrets, your keys. We say that you're using some keys to access an API or a database or any third-party system. It will be in memory, in some memory space. take a memory dump, you can totally see it. Confidential computing provides this new level of protection that is hardware-based. So there is specialized hardware, specialized CPUs by Intel, AMD, that provide encryption of memory space. So that memory is completely invisible to anybody outside of that memory space. So this is called confidential computing. Confidential computing is all about protecting access to memory. It is in addition to data being stored in a database in a file system. It is in addition to data being transferred. It is when data is actually in use and you want to prevent access to that data. Who can access then the data? Only the application that runs inside the same memory space. These memory spaces, they're technically they are called enclaves. They are black boxes. So anything that runs inside this black box is completely isolated from the outside. No one can access it. Only the application inside the enclave can process that data. And this is fantastic if you think about it, because not only you're protecting your data, but you're also protecting the application that is running inside your data. So this prevents the injection of malware that can compromise the execution of your application. And also, in some way, protect also your IP, your intellectual property, because if you're running a machine learning application and using a programming language like Python, for example, these are programming languages that can be easily reverse engineered. If you have access to the application, the executable, you can reverse engineer and get the source code and then reveal the algorithm that has been used for your machine learning, for example. By running this application inside an enclave, you're also protecting the code that executes inside this memory space. But one of the attributes that I really love personally is that you can remove trust even in the cloud provider. So the code and data that runs inside a confidential environment, they are completely opaque, invisible to the cloud provider itself. So it's like you customer give to Microsoft and the like some data, they protect it, but they never access it. They can't access it because it is in this black box and you only the owner of the key to access the black box. Now, one technology that enables this confidential computing is called Intel SGX. So Intel CPUs that have a software guard extension is an extension to the CPU that contains the wired encryption key inside the CPU. Each CPU is unique. So basically, any infrastructure that sits on these CPUs will leverage the power of hardware-based encryption. So best of performance, obviously, because it's hardware-based. There are no software libraries, and obviously software libraries can be compromised, can be hacked, and also represent an additional element to run. So hardware-based encryption, best of performance. The only way to hack a CPU with Intel SGX extension is to tamper with the CPU itself physically. So, good luck with that in some way, right? So you have the host, you have the CPU with a special extension. Then on top of that, you have the physical server, the bare metal, with the hypervisor. Inside the hypervisor, you run all your virtual machines, all your containers, and inside, obviously, the virtual environments, you have all your applications. In that moment, a memory space inside the guest operating system is reserved directly from the CPU. So bypassing the operating system, bypassing the hypervisor, going straight into the CPU to limit the action. And what I mean is that if you're familiar with the way memory addresses work is that the operating system, the kernel of the operating system, asks the CPU to provide the access to the memory. And the access to the memory is identified by an address. So if we were to take a memory dump, so if we run a tool like WinDebug, for debugging a memory space, the CPU will tell you that this memory doesn't even exist. You don't get something like scrambled data that looks encrypted. No, you actually get nothing. It's like the memory space has been completely removed from access from any unauthorized application. Some use cases, just to give you some context, we use this technology a lot in what we call multi-party computing. For example, banks, they use machine learning to prevent fraud detection or to prevent fraud. So we need to run machine learning for fraud detection. If you run a machine learning with just one data set from one organization only, you get some result, obviously, but it is limited in the capability of and accuracy of this machine learning. If you know how machine learning works, the larger the data source input, the more accurate is the prediction, because there is more data to analyze, identify patterns, and then make a scoring, as it is called, on potential output of this machine learning algorithm. So working with larger data set means that we can increase the accuracy of prediction, we can increase the detection rate, and reduce false positives. How can we work with multiple data sets? And we ask other banks to contribute to this machine learning, create a little consortium where multiple organizations, and this doesn't apply only to banks, it can be governments, in the healthcare, trying to find a cure to some diseases, vaccines, multiple healthcare organizations can work together and share patient data, or in the case of financial institutes, they can share financial transactions. Can they trust each other? Well, with this technology, they can, because they share the data not among them, but they share data with the central machine learning, in this case machine learning, but it can be anything that runs inside the enclave. And only the application that is installed inside the enclave can actually access this data. So bank one shares the data set encrypted with their own key. Bank two does the same, and so on. No one can access the data. Only the machine learning application that has been installed to execute inside the enclave. Obviously, as part of this consortium, the banks trust and agree on the machine learning algorithm, which is most of the cases is developed together and is open source. So they can completely see what's happening. There are no backdoors and all these sorts of things. So they trust the code. They, as said, more likely develop together, but then they don't trust the data that they share with the others. Only this machine learning algorithm can access this data. Now, let me show you this in a quick demo in the context of a database. A relational database, what happens? That you have some data that is encrypted inside the database, right? And then you have a database administrator that is running some profiling on the query. But hold on a moment. One of the critical aspects of protecting sensitive data is to encrypt data in the database. As a DBA, as a database administrator, if I can profile a SQL query, I can actually see the SQL expression, the statement that is running the query. And if the SQL expression contains some variables, like where, like some search conditions, where conditions, well, I can actually see that some pieces of this sensitive data. Not all of it, because all of the data is encrypted in the database, but some of it will be visible in the query. That doesn't sound good. So confidential computing can help protecting even the SQL query. So the DBA will not be able to see which query, or well, they can still see the query, but they don't see the data that is being used inside that query. So let me show you this in action. I just recorded a quick video. We are inside a SQL server database with this tool where I'm encrypting some keys. So you can see that I'm protecting the employees table, the SSN, and the salary columns with encryption and rest. This is purely encryption and rest yet. Okay, so this is just to say, hey, database, please protect these two columns. Now I go into my web application and I run a query to display a view, to display all the employees with their social security number and their salary, so sensitive information. On the web, this is displayed, but what is the query that is executed? So there is a query that does a select of some columns from the employees table, and then if I apply a filter, salary range or search by social security number, all these values will come up in the query. But with a confidential database, in confidential computing, the parameters, now you can see the search pattern is completely encrypted. So I don't see the search parameters that are passed from the web to the query itself. I see the placeholders, I don't see the actual value. So as a DBA, I can still do my profiling, I can still do my troubleshooting of queries, but I don't see the actual parameters that are the actual values of the parameters that are coming from the web application. They're completely encrypted. Obviously, the SQL engine is able to understand what these encrypted values are, and these are hardware encryption, as I said, and process the query normally. So indeed, this capability in a SQL database is called always encrypted with secure enclaves. It is always encrypted because data is always encrypted inside the enclave. So it never leaves the enclave in an decrypted format. But it's also secure enclaves. So it means that all the visibility of data is only happening inside the enclave itself. So we have a secure computation inside the enclave itself. The SQL database engine works inside the enclave in complete isolation, and also encryption and decryption are in place. So data never leaves the enclave in clear text. Now, if you were wondering, if you never heard about this confidential computing before, and you were wondering, but what is it exactly? What can is something that Microsoft is doing, something that AWS is doing? Well, this is actually a Linux Foundation organization called CCC, Confidential Computing Consortium. Confidentialcomputing.io is the website, and is a Linux Foundation, is an open source community, so there is nothing proprietary here. So players, founders of this consortium, they are working together, Microsoft, Google, Intel, even Facebook, even Oracle, Red Hat. So they are working together to provide an open, transparent platform for running confidential computing in the cloud to protect your data in the cloud and preventing this from the cloud provider, preventing access from the cloud provider. So if you want to learn more about, I have personally written a couple of articles. So what I'm going to do, I'll put these two links in the chat, so you can. So I'm trying to get to the link in the doing some silly things PowerPoint. All right, let's do that. I stop the sharing for a moment and trying to get the links so I can share the links with you in the chat. But happy to give you access also to the slide after this event. Let me go here, put this in the chat, type, send it to everyone. Here we go. First article, which is a sort of an overview of Azure Confidential Computing. So the way Azure provides this confidential computing capability. And then there is another article that goes a little bit more in detail on the multi-party, so the machine learning use case that I briefly presented before. Okay. Now, if there are any questions, happy to take it now. Otherwise, let me also share my contact details very briefly, so you can get in touch. Twitter, LinkedIn, whatever is easier for you. I'm not on TikTok. And then, yeah, get in touch. Ask any questions also after the session, and let me see how this technology can help you protect data in the cloud. Now, so before we close, any questions for me right now? Any doubts, any fears? Everybody's very quiet, so I'll leave it back to you. Thank you very much for having me today, and enjoy the rest of the masterclass.
Thank you so much, Stefano, for joining us and for your perceptive and informative presentation. And thank you so much for your time. And I'll ask the audience that if they're having any question, they can ask you in the chat or in the QA session. And Stefano is here to answer all of our questions.